In this lecture, we're going to look a little bit at what happens when you have multiple equilibria reactions occurring at the same time. So let's start by saying that it's complex. It's really complex. I mean, when you have just one equilibrium reaction occurring, it's something that you can do a calculation on with an ice table. And when you have two, you could, especially if they're cascading equilibria, you can imagine doing a series of ice tables, breaking it apart one at a time. We did that with some of our acid-base chemistry for polyprotic acids. But when you have chemical reactions that are both in equilibrium that are affecting one another, but maybe not in a directly cascading way, that like a polyprotic acid, then it becomes a challenge to be able to keep track of what's happening. And so precise calculations aren't really possible all the time with multiple equilibria. And I'm not going to set the expectation that in this class you're going to figure out how to handle some of these more difficult and challenging problems. But we can still use what we know about Le Chatelier's principle to make predictions or explore the effect that ion increasing concentration or decreasing concentration might have on a different equilibrium in the same system. And where this gets interesting is ocean acidification. So here we go. Ocean acidification is in part caused by an increase in carbon dioxide in the atmosphere. So imagine we've essentially increased the partial pressure of carbon dioxide at the surface of the water of the ocean. So just like my soda stream, in case anyone still has one of those, when you pressurize, you're putting greater pressure of carbon dioxide over that surface of the water, more of it dissolves. And it doesn't just dissolve, carbon dioxide dissolves more than you would expect just because it actually undergoes a chemical reaction with water. Water and carbon dioxide will actually form bicarbonate, which is this HCO3 minus. Now, when it does that, it's going to have a leftover proton that essentially makes that solution acidic. This is why soda or pop or carbonated water is actually acidic. It's terrible for your teeth. If you want to improve the enamel of your teeth when you drink lots of carbonated beverages, drink them through a straw because it pulls out more of the carbon dioxide into a gas state and helps it dissipate the bubbles more, or so I hear. I realize I actually just heard that from a chemistry teacher in high school, and I've been carrying it with me as knowledge my whole life, but I never actually double checked it because I learned it when I was 16. So double check me. So as that carbon dioxide dissolves more in water because we have more of it in the atmosphere, we're going to see the pH of ocean water decrease. The acidity increases, even slightly, right? And so we have all this bicarbonate around from just that. Now let's think about coral, and let's think about coral calcification. An important piece of coral calcification is carbonate, right here. So carbonate ions will react readily with any sort of acidic proton around, especially from a hydronium ion if we've increased the general decreased the general pH of the ocean. Sorry, I keep flipping that. And when those two react, they form, guess what? Bicarbonate again. So we actually form a lot of bicarbonate, either from the carbonate in the ocean or from the carbon dioxide dissolving and reacting with water in the ocean. Oh, and sorry, this is the super depressing picture of what happens. One of the consequences of ocean acidification is beautiful, vibrant coral reefs die, and all of the life that they support can no longer be supported, and it drastically reduces our biodiversity in the ocean. And so here, this is showing that same reaction, that the carbon dioxide and the carbonate ion are all essentially having a net overall reaction to form a lot of bicarbonate in the ocean. And so that decrease in the carbonate ions in the ocean because of the slightly more acidic water is actually what inhibits calcification in coral reefs and prevents their growth. Just depressing. And I'll leave it at that. These review slides are on the Canvas site as well. It's just reviewing the material that we went through in the previous lectures.